Welcome everyone. Let's solve the following integral examples. Our first example is integral of 4x cubed minus 4x plus 3 dx. We will use the integral properties. We will separate this integral into three different integrals. Minus 4 integral x dx plus 3 integral dx. This integral is equal to x to the fourth power over 4. This integral is equal to x squared over 2, and this integral is equal to x. These 4's will cancel each out, so x to the fourth power minus a division here, negative 2x squared plus 3x plus c. It was a really simple example. Let's continue. Integral of 3 to the x e to the x dx. If this was in the form of a to the x dx, we would know that the answer of this is equal to a to the x over ln of a plus c. But this is in a different form. Therefore, let's write this as 3e to the x dx. Now this is equal to, because of the rule we know here, let's use this, 3e to the x over ln 3e plus c. But I mean, I could leave it like this, but let me work on it a little bit more like this. Ln of 3 plus ln e is equal to 1. C. Next example, integral of x squared minus 1 by x minus 1 cubed dx. I don't want to expand this 3 times. Now, we didn't learn u substitution yet, but let's try to understand it by thinking, first of all, I know this part is square of the difference of squares. So this is x minus 1 by x plus 1 by x minus 1 cubed dx, which is equal to x minus 1 to the fourth power by x plus 1 dx. But still, the issue is here, right? Because I don't want to expand this 4 times. What can I do? I will say x minus 1 is equal to u. Because u to the fourth power is pretty easy to integrate. Everyone can integrate this. And from here, differentiating both sides, dx is equal to du. I know what to write instead of dx. I know what to write instead of x minus 1. What about x plus 1? Let's figure that out. X plus 1 is equal to u plus 2. If I add 2 to the both sides. Now let's plug these in. Instead of x minus 1, I have u to the fourth power multiplied by x plus 1 is equal to u plus 2. Dx is equal to du. This is equal to u to the fifth power plus 2u to the fourth power du. Everyone can solve this integral. We don't have enough space. I'm gonna continue here, maybe like this. U to the sixth power over 6 plus 2/5 here, right? So yes, u to the fifth power plus c. The issue is I don't know what u is. This is something I created. In the problem, there's no u, so we need to substitute this back. X minus 1 to the sixth power over 6 plus 2/5 x minus 1 to the fifth power plus c is my answer. Again, I don't want to expand this 10 times, so what am I going to do instead? X minus 5 is equal to u. Dx is equal to du. Integral of u to the power of negative. Okay, let's not skip the steps. 1 over u to the 10th power du. This is equal to integral of u to the power of negative 10 du. This is equal to u to the power of negative 9 over negative 9 plus c. Again, I don't know what u is. I have to write that back. Negative 1 over 9 x minus 5 to the power of 9 plus c is my answer. Integral of 10 squared x dx. I don't know which function I differentiate gives me this integrand, but I know that 1 plus 10 squared x is equal to secant squared x. If I leave 10 squared x alone here, 10 squared x is equal to secant squared x minus 1. Let's write this instead of 10 squared x. Integral of secant squared x minus 1 dx. We can separate this secant squared x dx minus integral dx. Differentiate, which function I differentiate gives me secant squared x? Obviously 10x minus x plus c is my answer. It was a simple exercise for us, the first page. Now from the second page, I tried to write kind of different problems. Show that the followings are correct. Okay, so this is saying, look closely. These integrals are the same, but they have different answers. We don't know how to integrate this yet. I will tell you how to anyway, so you can try it by yourself. You will have to make a u substitution here. You will say u is equal to cosine of x or u is equal to sine of x. Both works in this situation. And you need to figure out what dx is. But as I said, we will learn that in the next video. For now, let's differentiate the right sides with respect to x. Let's differentiate the option A first. 1/2 sine squared x plus c constant here, c1. Okay, constant differentiated is obviously 0. So we need to differentiate the right side from calculus 1. Have a rule. I mean, of course, there's a chain here. We need to differentiate inside. This 2 will go to the front. 2's will cancel each out. Sine x, differentiate sine x, cosine of x. This is my answer. Now for the b, negative 1/2 cosine squared x plus c2. Again, constant differentiated as 0. We proved the theorem related to this in our first video as well. Okay, the power comes to the front. These will cancel each out. Negative cosine of x, differentiate cosine x, negative sine x, which is equal to cosine of x by sine of x, which is equal to each other. What should we understand from here? We should understand that an integral can have different answers. Just because you found a different answer, it doesn't mean that it is wrong. As we can see, these are not equal to each other, but still both of these functions are the answer of this integral. Given the functions, we have two functions here. Show that both functions are antiderivative of the function given to us. What is the relationship between these two functions? Of course, first we need to differentiate these two functions with respect to x. 1 over 1 minus x. This is equal to 1 minus x to the power of negative 1 differentiated. Negative 1, 1 minus x to the power of negative 2 by negative 1, because differentiating inside is equal to 1 over 1 minus x squared. Now let's differentiate the second function, x over 1 minus x differentiated. Division rule, of course, 1 minus x minus plus x over 1 minus x squared. These will cancel out. 1 over 1 minus x squared. So these are equal. As we said, both functions are antiderivative for this function. What is the relationship between these functions? To talk about that, of course, what can we do is our first function is equal to 1 over 1 minus x. And our second function is x over 1 minus x. We said that the difference between two antiderivatives is a constant. So the difference between these two functions, since both of these functions are an antiderivative for the function, the difference between them has to be a constant. Let's try to show that. How can we do that? Let's do f1 of x minus f2 of x is equal to 1 over 1 minus x over 1 minus x, which is equal to 1. So f1 of x is equal minus f2 of x is equal to 1. You can say f1 of x is equal to 1 plus f2 of x, the relationship between two functions. I think this is a really nice problem in this topic. Hope that we could manage to explain. Find f of x for the given integral. Okay, since I don't know how to integrate this, I have one choice, and it is integrating this part, right? And integrating this part does not look fun at all. Do we have any other option? Probably not. Yeah, we need to differentiate the right side. Okay, then. Constant differentiated as 0. Anyway, let's apply the multiplication rule first, or I can multiply 3x cubed. There's a 9 there, so we can write x cubed ln x over 3. I'm multiplying these terms. Minus x cubed over 9. And I'm differentiating this. I already assumed that I differentiated the constant. Now, of course, I need to apply the multiplication rule. 3x squared ln of x plus 1 over x by x cubed over 3 minus 3x squared over 9. This is equal to 3x squared ln of x plus x squared over 3 minus x squared over 3. Everything looks good. I can simplify some terms. 3x squared plus, no plus, ln x over 3. Did we miss anything? I don't think so. And these will cancel out, so x squared f of x was equal to x squared ln of x. F of x was ln of x is my answer. Find the values for the given integral. Okay, we don't know how to integrate this yet. We will learn how to, but we don't know right now. So we have no choice but to differentiate the right side. Again, let's think what is the best way to differentiate the right side. Do we multiply the terms or we just apply the differentiating rules? It looks like we can apply the rules immediately, or maybe, yeah, let's do that. 2xk plus L by e to the x plus ax squared plus lx plus m e to the x, c differentiated is equal to 0, is equal to x squared e to the x. Now we need to solve this equation. I have 2 e to the x as mutual here, so this will be 2xk plus L plus kx squared plus Lx plus m is equal to x squared e to the x. Of course, this part will be equal to x squared. But it's not easy to see. Maybe. First of all, m has to be 0 because there's no constant. I know m is equal to 0. Okay, this one is gone. There's only one x squared, right? Only this is x squared. Oh, then k has to be 1. This is 1, so this is 2x here. I said k is 1. There's a plus L as well here. Lx. 2x plus Lx. Oh, m cannot be 0 then, right? I just realized. Wait. Okay, I know that k is equal to 1. I thought wrong there. M cannot be 0. Okay, k is 1 because there's no other constants that I have that includes x squared. Okay, now 2xk plus Lx will be equal to 0. And L plus M will also be equal to 0. I know k is equal to 1, so there is 1 here. 2x plus Lx is equal to 0. L is equal to negative 2. And M is equal to 2. If we did not make a mistake, this is the answer. You can check it. F prime of x is given to us, and f of 1 is equal to 2. These are given. Find f of x. If I integrate this, I will get the original function. Let's integrate this function. This gives us integral 2x plus 3 dx. This is equal to f of x. This is equal to x squared plus 3x plus 3. I'm kind of getting tired. Okay. So f of x is equal to x squared plus 3x plus c. f1 is equal to 2. Let's plug in. 1 plus 3 plus c is equal to 2. 4 plus c is equal to 2, c is equal to negative 2. Find fx, so f of x is equal to x squared plus 3x minus 2. It is known that for a positive function f whose derivative is equal to 2 times itself and f of 0 is equal to 1, find f of x. The problem states that derivative of the function is equal to 2 times itself. And of course, f of x is equal to y. What else is given to us? f0 is equal to 1. Okay. This is a differential equation. We don't know how to solve differential equations yet, but still we can understand this with what we learned until now. Instead of f prime of x, I can write dy by dx. And instead of 2f of x, I will write 2y. Alright. This gives me, what does this give me? 1 over y dy is equal to 1 over 2 dx, or wait a second. Did I write it correct? 1 over 2 dx, 1 over 2 dx, 2 dx. Integrating both sides, ln of y not absolute value because it's a positive function, is equal to 2x plus c. I need to add the constant to only one side. Now I can write y is equal to e to the power of 2x plus c from here, from the properties of ln. I know f of 0 is equal to 1, so if I write 0 for x, y will be 1. Y is equal to e to the 2x by e to the c. 1 is equal to 1 by, or let's write it anyway, 0 to the c. 1 is equal to 1 by e to the c. E to the c is equal to 1, so c has to be 0. The question was asking the function, right? So f of x is equal to, from here, e to the 2x.